this. Um, so plastic. One thing about seasteading and Plasticrete, how I'm gonna marry them together. And this is a video where I marry them together. This is the pause I take, trying to put it together. Plastic, floaty. Plastic. This is a plastic film. There's lots of it around, lots of different applications. This is what's considered a single-use plastic. They use it to wrap. Do I have any pictures? Insert picture here of it wrapped. And basically, it gets dirty and it gets lots of holes in it, and it gets thrown away. There's lots of material. That's from the material side. There's a lot of this. There's a quantity of it out there. So the economics work because you can get this stuff for now. It can't be utilized. There needs to be some modicum of cleaning, but even just like that is good. It doesn't need to be brought to a incredibly high degree of cleanliness. The layers. What I'm gonna do is I'm gonna take this and I'm gonna wrap it around something, a form, right? And multiple layers, and it gets wrapped around tight, somewhat tightly, not like super tight, but it's wrapped around on a nice, fairly even trajectory. And you get multiple layers, and then you encase the whole thing in this hot sand. And what the sand does is it creates a sort of energy source. It heats up the material, the film, and it fuses all the pieces together. So it doesn't get hot enough to melt it, and it's just sort of this sort of process, this magical process. And there's a fairly large window of temperature that you can utilize. So you could heat up this quantity of sand using the sun, and you take these forms, wrap them with plastic, and encase them with hot sand, and you wait a day for it to cool down, come back to temperature. You remove all the sand, and now you have this crusty plastic sheet, and it's almost to the point of plate. But you can do it again and create as many thicknesses as you need to get the desired material that you would want. And now you make these cells out of this plastic. You don't need to yell, Pete. They're right there. They're right here, in fact. Don't need to yell. Try to take it down a bit. Okay. So where were we? Okay. So you're able to create these structures, these cells, if you will, that fairly easy to manufacture. You would just get the actual shell, and then you would fit out the inside accordingly. But these cells they're hexagonal, but they also have a slight camber, right? So they come out a little bit as well as going up, and it's got 6 sides instead of 4. And that extra 2 sides gives this sense of warmth. It gives this sense of it's less angular. It's just softer. It's a nice shape. And how you can create these cells, and then you link them together in a ring because they're fascinating, faceted. They kind of create this. Do I have a little thing I can point my finger at? I'll get a little thing to point my finger at. So that's the sort of ring that you're able to make that float. And then you have multiple cells going under and over the water. The ones under the water provide stability. They're filled with water. And the ones above it are filled with air. And you basically create this. Eventually, I like to make a spiral, but, let's walk before we... Anyway, that's the basic concept, is you make these cells out of plastic waste, using the sun's rays and sand, that most of it is reclaimed. Just keep reheating the sand, and that's it. And you make these cells that can be constructed in a manner that is very strong. And so you have these interlocking cells going all the way around. And then there's these cables or some sort of structure that goes to the two other corresponding cells. So there'll be this triangle within this ring. And then the one over here has another triangle that goes and connects to there, and they weave in and out, and they weave in and out. And then there's another one. There's another one, right? I don't know how else to describe it, but me going, saying shit like that. Anyway, thank you for. I'm actually in frame. Oh, cool. Not in frame.